So who has that problem up?
What problem?
The we do.
I got it. No problem. I got it.
Because I can't change the
You go ahead, read it. Go ahead.
A circuit consists of 3 resistors connected in series to a 59.89 volt battery. The current in the circuit is 1,665 amps. Given that R1 equals 357.77 ohms and R2 equals 299.65 ohms, find A, the resistance of R3, and B, the potential difference across the resistor. Hint, page 757.
Very good. Okay, here we go. Once again, right? Don't put your hand in there, Aiden. That's the quickest way to get bit.
Oh yeah, hey, one of them.
I gotta watch every That's a snapper.
Be careful.
They both bite though.
Yeah, they bite. But he bites harder, so no.
that
And you still gonna stick your finger in there. So, well, I say, tell kids to do something, they still do it, huh? Alright, so what are we doing here, right? Well, we need 2 tools, right? So, since Aiden got up, I can change the screen, I guess. I'm glad I got those parent eyes. I can just look and see when y'all sometimes we look over there. Alright, I'm gonna put this problem on the screen so y'all can see it. Alright, so that's the problem. Let's work it out. So we need, of course, for a series circuit. Anthony, bring your behind back over here. I see that. You think I'm playing with? Come on, I see. You was doing good. As soon as you got back there with Dre, I hear conversation. Come on. Now I gotta have a brush off you, Doc. Because you got a lot of notes to take. Come on, have a seat. All right, now we have REQ is equal to R1, right, plus R2 plus R3. Plus
Dot.
Okay? So let's move on. We also need
I'm sure you want for this. Of course not.
Ohm's law, right?
No.
And that's how V is equal to I times R. Let's keep in mind there's another flavor of this. This is known as Electromotive Force, epsilon. Rush needs to sit down so I can see him do his work. I can't see his laptop from back there. He's not doing that no more. And I just caught him and Dre talking. Sit down here and let's do your work. Come on. I'm not playing with y'all. Okay. All right. No, right here, so I see your laptop. That's what you agreed to. He can't do his work out there, Rush, so I don't know. He's got to sit there so I can see his laptop. That's all I'm saying. All right, so anyway, it's known. Unknown.
I'm sure you want to just I already did it.
So let's put it all together, right? What are our values? Let's look at this problem slowly. We got
0.1.
What is that though? What do you think it is? What are these variables? What is it?
It's not amps. It's
It is amps. What is it? What letter is it?
R1.
Nope. It says R1.
I don't know.
Current. So she said 0. No, she said 0.1. She might have skipped over the epsilon. I didn't give you points, Mark 1. Right. But she said 0.1665. Brooklyn said it. So that's I. Because that's amps, right? That's our current. 1665. Keep up with your points, Brooklyn, because you got 5 for that. Marquand gave us epsilon. And what do you think that is, Marquand?
595.
Yes. What?
Oh, go.
There you go. He had to read it. All right, 59.89. 59.89 volts, right? What else are we getting? It's very obvious. Just read the problem slowly.
The
Okay. Everybody said R1. What is R1?
I said R1.
Oh, we got R2.
357.77 ohms.
Okay, you gotta say that. Y'all been giving me numbers. Y'all gotta say the rest, man. If I ask you how much you weigh, Andy, you're not gonna say I weigh 100. You gotta say 100 pounds, right? Okay. Not 100 apples, not 100 oranges, right? You gotta say the dimension. So for R1, it is 357.77
Ohms.
Masons like that word. Number 357. All right, R2. Somebody said they had that.
299.65.
Okay, all right, 5 and 5. Okay. Quiet. All right, R2
Ohms.
is going to be 299.65 omega. All right, what are we looking for here? Anybody know? Unknown.
R3.
R3. Yes. Y'all should have notes on how to do this from yesterday, by the way.
I don't even know how I know this stuff.
This is part A, right?
Mm-hmm.
You also need REQ to get R3. Okay? And I gotta move a little fast because it is 2:05. We got to 2:30, so it's like 25 minutes of class left, right? So let's move fast. Part B is going to be what?
V1, V2, and V3.
Yeah, better, yes.
So
V1.
That's 5
volts. V2, question mark, volts. V3, question mark, volts. All right, so let's box this off. Let's rock and roll. Let's get rid of all of this stuff by taking care of the problem. All right, 8 down, bottom of the ground. Dang. Sorry, it's my thing. Who else? Let's see if can I put the chips in the back on Russ's desk? Sorry. All right, cool. Trying to cut back on that stuff. All right, so what do? You're trying to get to R3, which means R2. You get it from here. So let's write it. Solve. This is step 1, right? Which is still all part A. So call all of this part A. So step 1, what do? You're solving for
R3. My bad.
Yeah, REQ.
My bad, I'm sorry.
Oh, here we go. Do not confuse the old black physicists, man. Like, you work years to get this way. All right, so how do you do that? Use this equation here, because we have all the values we need.
So I times REQ.
That's right. We're going to go epsilon is equal to I times REQ, right?
Mm-hmm.
Hey, we're recording. Come on. Giggle factor. We call each other. All right, so let's write it again. Now, I wrote it again because I want to do some algebra on it.
So whatever you do to one side, you do it to the other side?
Right, and what do I do?
Divide.
Divide by what? Finish off before you take it.
REQ?
Nope.
No, I already said it. I already said it though. I already said it. I don't want to hear it. No. What? Alright.
So, we're going to divide. We got I. Let's do one side. Hey, what's going on? What's the cord?
We clapping for the rock.
I'm going to need your spot here over there, Rush. I don't know. You started stuttering.
You're trying to hear the video. Y'all messed up the video.
This video is for some students that are not here or need it later. So please try to be mindful of that. REQ now is alone. Epsilon over I. Now we can plug these numbers in because we had. That's why I did that, right?
So I equals 0, 1 point.
Hold on. REQ is equal to, what's your epsilon? 59.89
volts.
Right?
divided by
0.166 amps. 5, my bad.
Oh, thank you. I heard that. Who has this answer for this section?
359.7.
Okay, I see you.
You gotta show me your work. You got it on your computer or you got your
Calculator.
I already cleared it though.
Oh, I can't give you the points though.
You don't do that to
I gotta check your notes. Huh?
Don't do that to Jamil.
Check it.
No, you don't.
You gotta check the notes. Like, you said the notes. Like, wait, chill.
notes.
I'm finna get it. I'm finna get it.
Said the notes.
Recalculate.
No.
Hurry up. It is 3:09. I'm sorry, 2:09. Let me see. 21 minutes left. Y'all have homework.
Huh? I don't know how to do this when I get home. No, I don't.
Alright,
Trust me, you do.
approximately
Yes.
0.7.
0.70. We can say 69. I don't know too far.
Alright.
359, you said?
Yeah. That's a 10, right?
Yes, it is. And that's measured in omega. So we got that part done. Now we can go back and get R3 here by doing some more out. We got RQ down. So let's go through it. We're going to say step 2, which is all still part A. Keep up. This is lots of right. Y'all be complaining as we do that. Step number 2, you're going to solve for R3 now. How do we get on tacos? Y'all some real kids. So REQ. I'm hearing tacos. I'm not hearing nothing about Ohms.
59.89. Oh, wait, never mind. My bad.
So now, our next step. So, hey, Jamila, this is going to be on the record. I'm going to send this to your people. Right? How did my class turn into a cooking class over there? Rush up, cheese on tacos? What are we doing? Tight. What y'all talking about? Call each other. Stop having these crazy conversations now. Give each other's phone number after you get out of school. Have those conversations at home, not here. I'll choose the wrong time that is. All right, so RQ, right? We got that, but we want to get R3. So let's do some quick algebra. So we're going to say, hey, minus R1, minus R2, because I want to get those over there. So let's do one side, do the other, right?
Mm-hmm.
Let's do R2. This will be R1. Right? So now I can cross out my R2 and R1. Leaving R3 all by itself. So let's rewrite the equation. This is a step. So I end up with a new equation, which is R3 equals minus R1 minus R2 plus REQ. Now, we're at the part where everybody loves, we plug in the numbers. Let's go ahead and do it. So we rewrite this. This will be
357. 35.
E equals minus, what
Oh.
do they tell me?
That's minus 297.73.
Huh?
Talk about
77.
Omega minus, we got R2, that.
299.65.
65 over
Omegas.
And yes, you have to use that symbol. Please do not put a W or some weird little letter in there. Plus, what's RQ? Well, we calculated it right here.
359.67 omegas. 69.
69. We didn't round it off by quite. I know what you're doing though. Just leave it at 69. And now the final part is you calculate.
What you get?
Oh yeah. Minus 297.
Ooh, you messed up.
I messed up? For real?
So,
Wait, no I didn't.
oh, you did it in reverse.
Yeah, I didn't mess up. I know what I did. I know what I did. I know what I
You
did.
did it from this way.
Yeah.
You threw me off. All right. So negative 297.73.
Yeah.
Okay. I'm gonna have to separate you, ladies. Is Hollis getting her work done over there? Cause I hear her. No. We typing. Y'all discussing. Y'all can do it in the hallway, and then they'll watch what you're talking about. Please get your work done, cause she needs the help. All right. So tell me the number again.
Negative 297.73.
297.73. Because we have a policy on non-educational discourse. So Rush, in a minute, I need your help to separate that party pack. Because I'm hearing all of it. All right, so tell me your number again, please.
What's the number?
Negative 297.9.73.
Well. Okay, yeah. Voltage drops. Let's go ahead and take care of this. So step number 3.
What's funny? What's
funny? For V1 and V3, right?
Mm-hmm.
So let's do it. It's real simple if you pay attention to this. So all you gotta do is what? Take V1 and what's its ingredient? I times the resistor it needs. So we got what? I
Times R.
R1. Look at V1. And what was these two? Let's plug it in. So we know current is, we got it here. Right?
0.166 point.
A is for amps, by the way. Multiplied by what resistor we got. I'm about to go sit next to
297.73 ohms.
Yes, 357.77.
Hey.
Right? So who has this one? This is another 10 point.
You got that one?
Yeah, almost.
You got that one, Andy?
Almost.
You got yours? You got yours?
One at a time, we have 15 minutes class. That's why I'm on everybody's case. I look at the grades, I know who's doing what. Listen, these conversations are killing me.
Oh, 59.56.
Can I see your calculator?
Alright.
You mean I? Yes. 5.7. Good job. 59.57 at 8 rounded.
Rounded.
Okay, 10 more points for Andy. Add points up. We need to do V2. What do you think V2 is going to be? It's real simple. Think about it. It's going to be, now currency is the same. V2 is equal to?
I times R.
Yeah, R2.
And then V2 equals to, you in my way, so I can't even tell you.
What do we got? So,
9.65, yeah. You got the answer for that? V2 equals. You got the answer?
Nope.
Oh, he said nope. All right. Do I got a calculator?
No, he doing it now, though.
Okay, I didn't know you 10 points now.
49.89, yeah.
Okay, let me write this here in case y'all didn't know. That's I times R2 and V2. Aiden, I can hear you, man. Come on, focus. So, what do we got? Yup, Addy got another 10 points, dude. Addy, you racking up.
Yeah, you passed me, my boy.
So, box that. Last one is V3. How do we set that up? Should be obvious, right?
Yeah.
Now we R3, so it can be V3 is equal to. And negative, I talked to a friend about this. A negative value can be used. This means that the voltage is going in a different direction. Right? So it's I times R3. And what we do here is we say, hey,
Could you remove the negative?
Well, he got it. You got to use negative, yeah. I talked to a friend at IIT, one of my old engineering buddies.
Well, I didn't use it yesterday.
That's fine. I didn't take off for it. Because I didn't go like, is that right? And he was like, yeah, Mike. You've done this before. What do we got?
Negative 49.5.
That's your calculator. Brooklyn, you got 2 points. She don't care. Use a trip with her. You use the negative as negative 49.57. All right. So,
Point what?
57, right?
Yeah, 57.
And that means that you have opposite voltage that's opposing in a different direction, as I was told. I got a lot of engineering buddies still. Okay, and this is all part of B. Ladies and gentlemen, this is the end of your We Do UC's problem again. I suggest you take all the notes and it up. It's easier than we do it. All right? You got 40 points. You know that, right? Because that's a long problem. All right?
I got more than 40 points, though.
Because you helped out.
Yeah.
That's why I'm recording. So you may want to hurry up.